Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because last night someone sent me an email, and basically they've got a homework assignment, which is California house prices. So basically what they did was they asked me for my, the first thing they did was they sent me an email and message, and they asked me to send them my code. And then they sent me another email telling me they had a homework assignment. Well, I'm not gonna send my code to someone who has a homework assignment because that's cheating. But I will go over the code for California house prices. The first thing you need to know is I'm using Google Colab, and they actually have California house prices in Google Colab sample data. I wish Google Colab had more sample data, but that's all it has is California house prices. So we're going to use the California house prices from the Google Colab, and how you get it is you can copy the path here, and that's how you get your California house prices. And then what we're doing is we're using Google Colab, which is a free online Jupyter notebook. So that's the great thing about Google Colab. So you don't not have to install a Python interpreter on your computer, which I prefer to do everything online. I don't really want to install anything on my computer, because when you install things on your computer, then you're opening it up to viruses. And since I've had my computer one time, I've had to do a reset on it. And when I did the reset on it, then it cleared out the interpreter that I had. So I just decided to keep my computer safe. I'll try to use online products, and Google Colab is an online product that you can use. So that's what I'm using to write this program. And after I've created the program, I've called it California House Prices Outliers. The first thing that you want to do is you want to import the libraries. So you import the libraries that you're going to use in the program, and you also import them as you need them. So I've imported Pandas, which is a library that creates and maintains data frames. I've imported NumPy, which is a library that carries out numerical calculations. I've imported Matplotlib, which is a graphics library that enables you to plot the data points onto a graph so you can see what it looks like. And I've imported Seaborn, which is also a graphics library, but a higher level than Matplotlib, and Seaborn is written on top of Matplotlib. I've also, as we progress through the program, I've also imported sklearn, which is a machine learning library. So this person that emailed me, obviously he's studying machine learning, so this is an assignment that he has been given. He also emailed me the data sets, and I think that he emailed me the data sets in Excel, but you need the data set in a CSV file. So we have our data sets in a CSV file. And then what we're going to do is we're going to read the data sets using pandas. So train equals pandas.pd.readCSV, and there's your train CSV, and then test equals pd.readCSV, and then you've got your test CSV. So now what we have done is we have converted these CSV files actually to data frames. Now you can see the train file. So what the label is median house value. And so you can see the train file is longitude, latitude, housing median age, total rooms, total bedrooms, population, households, median income, and median house value. That's your train file. Your test file has the same format as the train file because they also gave you the median house file in the test file. But if you were entering a competition, you would not be given the median house value. That would be blank. And what you would have to do is you would have to actually make a prediction on the median house value for the test set. But they haven't done that on this occasion. Okay, since the train file and the test file are of the same format, then what we did was we created a large file calling it combi, which is train.append test. So you have appended the test file to the train file. And then so now you've got 20,000 rows of data. Okay, so this is what we're doing is we're looking on the info, and you can see that all of the columns of data, which are also called features, are floats. And then we can check for null values. You can see that there are not any null values in the data set. So now what we're going to do is we're going to check the label, and you can see here that there's a lot of outliers in the label, and since there's a lot of outliers in the label, then that is actually going to affect your prediction. And your outliers are right here. These are your outliers. So what we're going to do is we're going to remove the outliers. And so this is a really simple piece of code that enables you to remove the outliers. So you can use this code for X in median house value, Q75, Q25 equals NP dot percentile, combi, LOC, X, 7525 interquarter equals Q75 minus Q25. Max equals Q75 plus 1.5 times interquarter. Min equals Q25 minus 1.5 times interquarter. Combi loc, combi X is less than min X. NP NaN. Combi loc, combi X is greater than max X. NP-NaN. And then so what that means is anything less than the 25 percentile becomes a null value, and anything greater than the 25 percentile, anything greater than the 75 percentile becomes a null value as well. And so we come over here, we've got 1042 null values. And then so what we're going to do is we're going to drop every row of data that has a null value. So combi equals combi.drop, axis equals 0. Drop NA, axis equals 0. So now what we've done is we've dropped everything that has a null value. So now you only have 18,958 rows of data because it dropped everything that was a null value. So now we check our disk plot again, and you can see that once we have checked our disk plot, the outliers have been removed. And the idea is that when you remove the outliers, you will get a more accurate prediction. So we've done another scatter plot, so you can see the scatter plot here, everything's gone. At 500,000 is your ceiling. And then you can see we have a box plot here. So you can see that as the quality of the house improves, the price of the house also improves as well. And now we have our we have our heat plot. And then so basically the idea is to remove all of the columns that have a high correlation, because if the column has a high correlation, then it's going to be redundant. And if I go over here, I think that I've got a piece of code for a high correlation, and we can put that in here as well. Come over here to competitions. Come over here to April 2022. I think what I put in here was a high correlation, code to remove a high correlation. Come over here to my submissions. Remove columns that have a high correlation. So what we can do is we can try to remove the columns that have a high correlation. See if anything drops off, and see if that improves our see if that improves it. See what happens. So we'll put some more code in here. So it took out 3 columns. So this had 3 columns. No, this had 9 columns right here. And when we checked all of the columns that had a high correlation, we removed everything that was greater than 90%. So, well, it took out the latitude, so we don't want to take out the latitude. So let's make it 95%. See what happens when we make it, because we want to keep the latitude, because the latitude helps us to, so it took out 1 column. So you've got your latitude, your longitude, housing medium age, total rooms population, medium age, medium house value. I think it took out median income. Now, households. So it took out households. It kept latitude and longitude, and it took out households. So so we'll leave that the way it is. We'll leave it at 95% the way it is, because I wanted the latitude and the longitude in there. And the only thing that it doesn't have is doesn't have households. So we created a map. So that's what I wanted. I wanted to be able to create the map. So actually, when we removed the that feature, it actually reduced our prediction. So that wasn't very nice. It wasn't very nice. The prediction was actually 92. So we'll just say 99, see what happens. See, anything that's 100%, see what happens. So now that's 9 columns. We've got our map, which I wanted. Yeah. And so it didn't actually improve the accuracy when we hold on a second. It didn't actually improve the accuracy when we took out the columns that had a high correlation. But if you have a data set that's got lots and lots of columns in it and you want to reduce the columns, then that would be a good way to reduce the columns and just reduce the ones that had a really high correlation, because what they would do is they would present a lot of redundant material, and this redundant material could introduce noise into the system. So in this particular instance, it didn't really work. It did not improve the accuracy. So we just left it at 99%. And so that 99% set, basically it didn't remove any columns. So we've got our heat map, which is what we had before. And we've got created the map, which is what I wanted. I wanted to create the map. And so we've created a map so you can see all of the houses, because this particular, that's how you create the map, because this particular data set gives you the latitude and the longitude, so you can create a map. And then we define our X and our Y values. So Y equals combi.median house values dot values. X equals combi.drop median house value. And then so the axis equals 1. We're going to normalize it. So the code for normalization is X equals X minus X min over X max minus X min, and that normalizes your data. And basically what you want to do is you want to take all of the data points in the data set and you want to convert them to a value between 0 and 1. And the reason for that is because it helps the model to make the prediction, is what it does. So now what we're going to do is we're going to use train test split to split the data set up for training and testing. So we're going to have 90% as the test set, as the train set, and 10% as the validation set. And now we're going to use the model. And in this particular instance, we used Grid Search CV. And so I did this last night, and I used Grid Search CV. I did this last night because this person emailed me about his homework assignment, in which I said I'm not going to send him my code, but I will do a review of the data so he can glean whatever information he can from a review of the data or review of the code. So it was late last night, but if it hadn't been so last minute, I probably would have selected a different model to use. But what we did was we used HIST gradient boosting regressor, and we use Grid Search CV. And what Grid Search CV does is Grid Search CV is a function that enables you to select the best parameters, because whenever you're selecting these models, you have to tune the parameters. And so we tune the parameters for loss equals least squares, max iterations equals 4,000, depth, max depth is 10, and random state is 1. And then we fit X train, Y train, and we had 88.7% accuracy when we did that. When we used it with Grid Search CV. And then we're going to make the predictions. So when we predicted on the validation set, ypred equals model dot predict xval, and then anything that's less than 0, we're going to make it a 0. And one thing, whenever you use standardization, there's always the possibility that you're going to have a value less than 0. But I knew that all of these values were going to be greater than 0 because it was going to be based on house prices. And so I decided to just use normalization because I just felt that normalization would give a better outcome. And basically what you have to do is whenever you are making predictions, you have to either normalize or standardize the data. And if you go into sklearn, they have functions that you can use to normalize or standardize the data, but I just prefer to use the formulas that I know. And then so ypred equals ypred.astype int, and then so what I wanted was I just wanted to make it an integer because the outcome is going to be a float, but I wanted to make it an integer. And then it says print the score, which is 82% accuracy, which is what I've been getting the whole time. And then we check our error. Our error is 40,413, so that's not fantastic. And then we plot the data points. We plot the actual values against the predicted values, and you can see that the predicted values are not up. You have some outliers and they're not up there against the actual values. And then what we do is we create a data frame to compare the actual values against the predicted values. So you can look at the actual values and you can see how they compare against the predicted values. And that's it really. And if you wanted to, because it's my alarm clock just went off, but if I wanted to, I could use like a different model just to see what would happen. So we can check just very quickly a model that I know. So we can compare linear regression against his gradient boosting regressor, and we can see what we get in that regard. So we come over here to sklearn. And we can see what we get when we use linear regression. Let's just see what our prediction is with linear regression. So you can see with linear regression, one, our accuracy went up to 89, and two, with linear regression, it was only 60%. And that's why some of these other models are better than linear regression, but sometimes that's all you can use is just linear regression. So the last time our accuracy was 89, but our prediction on the validation set is still 82%. So that pretty much covers this code review. We've done a lot of things on the code review. So we've done outliers. Outliers is something you can do to improve your accuracy. And then we've checked to see if any columns had a high correlation. But when we tested it, number one, when the correlation was 90%, it took off the longitude, I believe, and I wanted to keep the longitude in there because I wanted to be able to make a nap. And then when we checked for 95% correlation, it took out one column, but that one column it took out, it didn't actually improve the accuracy. So then we made it 99%, which means basically that it's not there at all. But that's still something you can use. You can use outliers. You can check for outliers to improve your accuracy. You can check to see if there's a high correlation in the columns. And if there's a high correlation in the columns, then you can remove some of your columns. In theory, that could improve your accuracy, but it didn't improve your accuracy in this occasion. And you can also normalize or standardize your data because that will reduce noise. And in this instance, I normalized the data because I knew all of the values were going to be over 0. So I think that concludes this code review. I'm running out of time, so I'm going to have to stop talking. And I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And I look forward to making more videos for you in the future.